Hi everyone and welcome back to NTE. My name is Tebi Singh and on this channel I create quality revision videos as requested by you. If that's something you're interested in, then please consider subscribing. Previously on NTE, we looked at question 7 from the February-March 2018 supplementary paper, and that question was dealing with annuities. However, in that video, I didn't explain to you guys what annuities are. Put simply, an annuity refers to a number of equal deposits or payments which are made at a regular time interval. This is usually at the end of each month. There's two types of annuities that we come across, the future value annuity and the present value annuity. Okay, so the future value annuity simply saves up money for the future, and the present value annuity pays back borrowed money. Both these annuities consist of regular deposits in terms of the future value annuity and payments when you're talking about the present value annuity, and you have an interest rate that is being charged with both these annuities, right? So an example of future value annuities are your savings account, your investment funds, your pension fund, and your sinking fund. And examples of your present value annuities are things like your loan repayments, your mortgage bonds, which is your home bond, and your cell phone contracts. Those are present value annuities. And if you go to the back of each and every question paper, you have your formula sheet. On that formula sheet, you're going to have the future value annuity formula and the present value annuity formula. Let's look at these formulas and I'll explain to you what each variable actually means. Alright, so on the left hand side we have our future value annuity formula, and on the right hand side I've written down the present value annuity formula. In both these formulas, the X value is your monthly installments. Okay, this is the money that you're paying into the account, and this monthly installment is the same value throughout your period. So that's the first thing that you need to know, that the X value is always the same, which is why we said that an annuity, remember, is a number of equal deposits or payments. That is that equal value, the value of X. Right. I, as usual, is your interest rate that is being charged. Interest rate. And N, it's the number of installments. In other words, the way you can think about it is the number of times you're going to make a payment. So when I say the number of times you make a payment, it means the physical number of times you're going to take out this value of X. You could be taking it out for 12 months. That will be a year. You could be taking it out for 60 months or 60 times. That will be 5 years, right? And usually these number of installments are given in terms of months, right? It's not always the case, but when you put it into the formula, you need to think about it in terms of number of installments. So just read your question. If they give you years and they tell you that your interest is being compounded monthly, then the number of times that you're going to make a payment is each month. So you need to convert those years into months. So let's just recap. In both the future value annuity and the present value annuity, your X value refers to your monthly installments. This X value is always the same value throughout your investment period or your repayment period. So when I say investment period, we'll be talking about your future value annuity, and if you talk about a repayment period, you'll be talking about looking at your present value annuity, right? I is your interest rate, and we always write down the interest rate in terms of decimals, right? And N refers to the number of installments that you're going to make, or you can think about it as the number of times that you actually make a deposit or a payment into your account. All right. Now what we're going to do is we're going to practice even further by looking at the November 2017 question paper, and I'm going to be looking at question 6. Okay, November 2017 question 6. Let's look at question 6.1. States that Mbali invested 10,000 Rand for 3 years at an interest rate of R, okay, per annum, which was compounded monthly. At the end of this period, she receives 12,146 and 72 cents. What we need to do is calculate the interest rate that was being charged in this investment. Right. So we have the amount that she receives right at the end. Okay. Now, this specific question is not an annuity. This is just your simple compound interest formula. So why am I saying that this is not an annuity? Well, because Mbali invested 10,000 Rand for 3 years. That's all she did. She went to the bank, she put 10,000 Rand into an investment account, and she left it there. You know, the investment account was earning a certain interest that which we need to calculate. It was earning an interest of, and after 3 years, this is what it returned. Okay, so they didn't say that she was depositing 10,000 Rand each month. If that was the case, then that would make it an annuity. So nowhere in this question do we see equal payments being made. And if you don't see equal payments being made, then you know that you're dealing with just pure simple interest or compound interest. In our case, we're dealing with compound interest. Right. So make sure that you read the question very carefully before you just assume things and use the incorrect formulas. Okay, so question 6.1. Right. Compound interest formula. A is equals to P 1 plus I to the N. Right. We know that the amount that she accumulated is 12,146 and 72 cents. She invested 10,000 Rand. 1 plus the interest that she was earning is a value of R, and this was being compounded monthly, so you have to divide it by 12, and she did this for a period of 3 years, so we have to multiply that by 12 as well. Okay, now what we need to do is we need to solve for the value of R. So let's start first by dividing both sides by the 10,000 Rand. So you have, okay, so 12,146 and 72 cents. Let's divide it by 10,000. And what you have on the right hand side is 1 plus R divided by 12 to the exponent of 36. Right. Now what I'm going to do is, in order to solve for this R value, I'm going to apply logarithms. Right. So I'm going to take the log of both sides, and the reason why I want to take the log of both sides is because on the right hand side that would allow me to bring my exponent down. Right. So remember in the laws of logarithms, so laws of logarithms. Okay, one of the laws states that if you have the log of a to the r, okay, okay, this is the same as r log a. Okay, so this exponent can drop down to the front, and that's exactly the rule that I'm going to apply in the next step. So first thing, I'm taking the log of both sides. So log 12,146.72 divided by 10,000 is equals to the log of 1 plus r over 12 to the 36. Okay, so then this 36 can come down to the front, so you have log 12,146.72 so equals to 36 log of 1 plus r divided by 12. Okay, so then now that I've done that, I can now divide the left hand side by this 36. So I'm going to have log 121,146.72 10,000. I'm dividing all of this by 36. What I'll have on this side is the log of 1 plus r divided by 12. Okay, now I need to get this value out, because what I'm trying to do is solve for r. Okay, now what I'm just going to do is I'm going to convert from log to the exponential version. Remember, a log is simply the exponent. So what is the base of a log? Base 10, and the log is equals to the exponent, so the left hand side becomes our exponent, very big exponent. So you have log 121,146.72 divided by 10,000. All of this divided by 36. Okay, so there's I'm changing it to exponential form. This is equals to 1 plus r to the 12. Okay, let me just explain what I did over there. So you're converting from logarithm, from log form to exponential form. So what I'm saying is, if you have the log base a of b equal to c, this is the log form. Okay, if you want to change this to the exponential form, this is equivalent to, right, the base a to c, because remember the exponent is equals to the log, so log is equals to c, so it means that c is the exponent. That is then equal to b, right? So what did we do? If you look at it over here, you've got base 10, so you have 10, the log is the exponent, so the left hand side became your exponent, equals to the value of b. So that's the theory that I applied on this side. Okay, hope that makes sense. Now that I have this isolated, it's very easy now to calculate for r. I'm just going to have 10 to this big exponent divided by 10,000. All of this divided by 36. Okay. What now we're going to do is going to minus 1. That's going to equals to r over 12. Then if you insert this into your calculator and multiply by 12 at the end, you can solve that your R value is equals to 0.065. Okay, so that's the value of R, but let's answer the question. Therefore, the interest that was charged is 6.5% per annum, compounded monthly. Compounded monthly. Okay, so there we go. Remember, this is the exponential form. Right. Let's go to the second question. Question 6.2 states that Pete takes a loan. Okay, there is a key term, loan, from a bank to buy a car for 235,000 Rand. He agrees to repay the loan over a period of 54 months. The first installment will be paid 1 month after the loan is granted. The bank charges an interest rate of 11% per annum, compounded monthly. Right. So there we go. Now we have an annuity. So question 6.2 is an annuity. Annuity. Okay. Why? Because we have a loan. Okay. And he's going to be paying off a loan, obviously, every month using equal repayments, right? And in this question, it is very nice. They gave us our period in terms of months, so there's no conversion that we need to make. So we have 54 months that we're working in, and he took out a loan for 235,000 Rand and is being charged 11% per annum. Right. Now remember, from the previous video, I told you that when you see the word loan, you are dealing with the present value annuity. Why? Because the present value annuity pays back borrowed money, right? Remember, the loan, you get the money today. So then when you pay it back, you use your present value annuity. Question 6.2.1 then states that we need to calculate Pete's monthly installments. So we need to calculate how much Pete is going to have to repay on a monthly basis. And question 6.2.2 asks us to calculate the total amount of interest that Pete will pay during the first year of repayment of the loan. All right, let us go. We have our present value formula. So x into 1 minus 1 plus I to the minus n, all of this divided by I. Okay, so Pete took out a loan for 235,000 Rand. Right, so we need to calculate his monthly installments, and he's being charged 11% compounded monthly, and he's repaying this over 54 months. Okay, so that's divided by 0.11 over 12. Okay, now in your calculator, you're just going to multiply by the denominator and divide by this term inside the bracket, that you'll be able to calculate that his monthly installments are 5,536.95. Okay, so that's how much Peter is paying every month in order to repay his loan. Right. Question 6.2.2. asked us to calculate how much interest he's paid just in the first year of repayments. Okay, so first things first, in 1 year, Pete pays a total amount of 12 times 5,300, 5,536.95. So in 1 year, Pete has paid 66,443.40. Right, now we need to figure out how much of this actually went into paying the loan. So we need to calculate how much he's paid off in 1 year, and in order to do that, we need to find the balance on the loan, or the amount that's outstanding, and then subtract this from the total amount that he took out. Then we're going to be able to calculate the interest that he was charged. Right, so in order to calculate the balance on the loan, we use the present value formula on the amount, on the number of time that is remaining. So if he's paid off for 12 months, the balance on the loan is 54 minus 12. So the amount remaining is, the amount of time remaining is 42 months. So that's the balance on the loan. Okay, so balance on the loan, or you can think about it as the amount outstanding. Okay, so we use the present value formula on the amount of time that is remaining. So he's paying 536.95. And we have 42 months that are remaining. So if you put this into your calculator, you'll find that the balance on the loan is 192,296.20 cents. Okay, so now the amount paid off in 1 year, amount paid off in 1 year is total loan amount, so loan minus the balance So in total he took out 235,000, and the balance is 192,296.20. So in 1 year he's only paid off 42,703 rand and 80 cents. Okay, this is obviously less than the amount that he's physically paid, in 1 year. So obviously there's some interest that's been charged. So the extra amount is the interest. So the interest charged is 66,443.40 minus the amount that he paid off, to 3.80. So just in 1 year he's paid off interest of 23,739 and 60 cents. So there we go, that's the answer to the second question. Until next time, bye.